This is Agi Promise, and you are welcome to Jamb Prime. So, on our last episode, we actually talked about some of the most repeated UTMA biology questions and explanatory answers. So, that was the episode one of the series one of that of biology. And today, we are going to be seeing some of the most repeated UTMA chemistry questions and explanatory answers. So what is this actually all about? So if you actually registered for chemistry on your Jamb examination, so there are some kind of repeated or most repeated questions you might likely see on the day of your examination. So knowing these questions and being able to provide answers and knowing why the answers are actually the answers, so I believe from there you should be good to go in any chemistry Jamb examination you are about to write. So okay, let's see this now. Some of the most repeated UTME or Jamb chemistry questions and explanatory answers. So let's see. Number one, here we have to have the periodic classification of an element is an arrangement of the element in order of their dash. A, atomic weight. B, isotopic weight, the molecular weight, and D, we have your atomic number. So what is actually the correct answer to this question? The periodic classification of an element. So the answer is actually D, which simply means your atomic number. So what is an atomic number? Or okay, elements in the periodic table are arranged according to their atomic number or the proton number. So the atomic number is also called the proton number. So you shouldn't be confused by the terms. Then note that an atom in general is actually made up of the proton and the neutron. Then in the shell of an atom lies an electron. So note that the proton is actually a positive charge, the neutron is actually neutral, and your electron is actually negative charge. So and you should also note that electronegativity actually increased from left to right, across the period, while atomic radius actually increased down the group on the periodic table. Note how to know a period or a group. Then, if you actually see your periodic table, the column, I guess you know a column, the vertical, yeah, is actually called your group, while your row, like the horizontal, yeah, actually called your period. Yeah. So but what you need to just note in this question is that elements in the periodic table are actually arranged according to their atomic number. Yeah, so let's move on to the next question now. It said if 1 liter of 2.2 molarity sulfuric acid is poured into a bucket containing 10 liter of water, it said, and the resulting solution mixed throughout okay, the resulting sulfuric acid concentration will be dash. So in this question, okay, this is actually coming from chemistry sociometry, and notes, okay, they actually gave you volume, which is mentioned on liter, and that of a 2.2 molarity or the concentration of a solution. So the if you actually did molarity, or so the formula that actually connects, yeah, the answer is C. So let's see why it is actually C. So molar concentration or molarity, which is given as M, is equal to the number of mole of substance all over the volume of a solution. The unit of volume can be given as L or decimeter Q. So let's find the mole or the number of mole of sulfuric acid that was poured in 10 liter of water. So when we actually find the mole, so from there we can now use that mole to actually find our answer, which is the sulfuric acid in 10 liters of water. Yeah. So looking at this now, knowing the relationship between your molar concentration, your number of mole and your volume. So it's actually giving us, like we said, the molar concentration is equal to number of mole all over volume. So that is the main formula you have to use in this kind of question. So okay, you can see 1 mole or 1 liter of 2.2 molarity. So you can do the calculation there. That is how you actually got 2.2 times 1 liter. So it will not give you 2.2 mole. Yeah, to give you 2.2 mole. So okay, calculating. Okay, now you actually have the mole, which is 2.2 of sulfuric acid in 10 liters. Okay, I had to actually find 2.2 mole of sulfuric acid in 10 liters of water. So you can actually bring out the formula again, which is the molar concentration equal to mole all over volume. So putting it into there, which is 2.2 mole all over 10 liters. So they're actually telling you to calculate how many like what is actually this. There's the resulting solution means shortly. Say the resulting sulfuric acid concentration will be dash. That's like, that is to say, the resulting concentration, or the resulting acid concentration on the 10 liters of water is actually dash. Okay, that's how we actually find it, which is the molar concentration equal to the mole all over volume, which actually give us 2.2 all over 10. So it's just a straightforward question. Okay, that's how we actually got 0.22 molarity. Yeah, so C is actually the answer to this question. So though we will actually see more on this stoichiometry if we actually go on, yeah, as we progress. So let's see number 3 question. It said, a correct electrochemical series contain to okay can be obtained from K NaCa, okay, LaMgZ, and FePb, HCu, Hg, Ag, and Au by interchanging. So in electrochemical series, okay, they just gave you something like this, and they are asking you if this is actually correct. So if what they actually give is not correct, so it's like they actually make, okay, what they actually gave you here is actually wrong. So they're actually telling you now to correct it. So what were you able to, or what are you going to interchange in order for this stuff to actually be correct? So let's actually see the electrochemical series and how it actually line up here. So aluminium is more reactive than magnesium. So in the electrochemical series is the use of standard electron potentials to properly arrange ions from most reactive to less reactive. So from this one now, they actually arrange like K, from K to or K, which actually means your potassium, your sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver before your gold. So on this step they actually gave you, so from your aluminium, magnesium, zinc, iron, okay, you actually have tin, but there was no tin there. Okay, all right. So from this one now, you actually see that your magnesium actually comes first before your aluminium. Yeah. So that is why it's actually wrong. So by interchanging aluminium and magnesium, so that is how you actually got your answer. But in this electrochemical series, so let me just give you a simple measurements you can actually use, like in terms of knowing this electrochemical series. So I guess this is not actually written, but let me just give you from your potassium to your gold. Okay, you can actually use these acronyms or monuments, like, which is, please stop calling me a zebra. Instead, tell Laura how copper help strengthening gold. You can take it down again. Please stop calling me a zebra. Instead, tell Laura how copper helps strengthening gold. I will go again. Please stop calling me a zebra. Instead, tell Laura how copper help strengthening gold. So from this one now, you can actually use the first letter of each sentence. Yeah. So from please, you actually have your potassium. From stop, you actually have your sodium. From calling, you actually have, so you can do it thing, you actually get to gold. Yeah, so that is a simple acronym you can actually use for this your electrochemical series. I hope you got that. So for the next question now, we actually have a basic postulate of the kinetic theory of gases is that the molecule of gas move in straight line, between collisions. This implies that, okay, this is a straightforward question. A, collisions are perfectly elastic. B, force of repulsion exists. C, force of repulsion and attraction are in equilibrium. And D, collisions are elastic. So what is actually the answer? The answer is actually B. Yeah, it's a straightforward question. Note that if you actually see that in the kinetic theory of gases, okay, like when they say gas actually move in a straight line between collision, it actually means that the force of repulsion actually exists. Yeah, so which is actually B. Yeah, so it's a straightforward question. You can actually note that. So on the next question now, we actually have, on which of the following is the solubility of a gaseous substance dependent? So on which of the following is the solubility of a gaseous substance dependent? So A, or they actually gave you different options, which is nature of solvent, nature of solute, temperature, pressure. So they are not asking you now, like, from this actually, like, give us the solubility of gaseous substance actually depend on how many of these characteristics. Okay, let's see the answer to this question number 5 now. So the solubility is the maximum amount of substance that we dissolve in a given amount of solvent at a specific temperature. There are two different factors that actually affect solubility. Number one, we actually have your temperature and your pressure. Note it. So temperature actually affects the solubility of both solid and gases, but pressure actually affects the solubility of only gas. Yeah, so note that temperature affects the solubility of both solid and gases. On the other hand, pressure actually affects only the solubility of gases. So note the nature of the solid also affects the solubility. So from these option now, we have the nature of, like, they are giving you now, okay, note temperature affects both gas and what, solid, why temperature actually, why pressure actually affects only gases. So from this option now, you can see number, which is 3 and 4 are actually correct. Then note the solubility of gaseous substance actually depend on the nature of the solvents, not the nature of the solutes. Yeah, so that is why D is actually correct. So to the next question now, which is question number 6. So he said, which of the following statements is correct about the periodic table? So A, elements in the same period have the same number of valence electron. Elements in the same period have the same number of valence electron? No. The valence electron of an element is the same, like in the same period, increases progressive across the period. Is it the answer? So let's see. C. Elements in the same group have the same number of electron share. The non-metallic property of an element tend to decrease across the period. So for this question, I will not actually have, I'm going to give you guys a tip on the periodic table and how this actually increases, but it's not on this question actually. But I'm going to give, I'm going to create a video on that, yeah, so you guys can actually get everything about this periodic table. But note that the answer is actually B, yeah. So option A is actually incorrect. Elements in the same period have the same share, but different number of valence electrons. Elements in the same period have the same share. Yeah, note, elements in the same period have the same share, but different number of valence electrons. Their valence electron progressive increase from one, like by one from left to right here. So option B is actually correct, yes. So the valence electron of an electron in the same period increases progressive by 1 as we move from left to right. So C is actually wrong or incorrect. Say elements in the same group have the same number of valence electron and not the same number of shell. Yeah, you can note this down. And this is actually correct because the non-metallic property of an element actually increase as we move from the left to right across the period. So like I told you guys, I'm going to give you guys that one on that class, yeah. So but just note these corrections down or these explanations down. All right, so to question number 7. So we actually have the boiling of fats and aqueous caustic soda is referred to. The boiling of fats, so this is a straightforward question, which is also known as saponification. So I guess a chemistry student should be able to note this, which is soap, a sodium, or they are sodium or potassium salts of long chain fatty acid. Okay. When triglyceride in fats or oil reacts with aqueous sodium hydroxide or potassium hydroxide, they are actually converted into soap and glycerol. This is actually called the hydrolysis of ester. Yeah, so you can also see question like hydrolysis of ester is actually called, the answer is also called saponification. Yeah, since this process actually led to the formation of soap, sorry, so it is actually called the saponification process. Yeah, sodium hydroxide plus fatty acid to give you soap and glycerol. So note it. So moving on to the next question now. Which of the following pair of substance will react further with oxygen to form a higher oxide? So you can note this question or you can note the answer because I believe this question is always repeated year after year. So they said number 1 is actually carbon dioxide plus water. So for this question, they're just asking you which of these oxide probably can further react with other oxide to form higher oxide. So you can see this oxide now. Can this oxide actually form higher oxide? So which of these one are actually correct? So they're asking you, number 1, we have your carbon dioxide plus water. Number 2, your NO plus H2O. Your 3, which is CO plus CO2. And your number 4, or your D, which actually have your SO2 and your NO. So what's actually the correct answer? So let's see explanation to this one now. So you say A is actually incorrect. See, there's no higher oxide of carbon other than your carbon dioxide. Yeah, you can note that. So carbon dioxide is, so there's no higher oxide of carbon other than your carbon dioxide. So although water actually have higher oxide known as hydrogen peroxide. So number 1 would have been correct, but CO2 there actually makes it incorrect. So let's see number 2, which is NO and um, NO2. So sorry, NO and H2O. So okay, so B is actually incorrect too. So what actually makes B incorrect? NO2, which is nitrogen 2 oxide, can further be like oxidized into the nitrogen 4 oxide, but water on the other hand cannot be simply oxidized into higher peroxide by simple reaction with hydrogen. Yeah, so note that water ordinarily does not react with oxygen. Yeah, note B would have been correct, or if probably okay, we haven't got it to D yet, but if probably there wasn't another answer, so would have picked B. Yeah, but based on this question, D is actually more correct than B. So that is why we actually so if you actually see B very well, water has higher peroxide known as the hydrogen peroxide, but in this question, oxide, like water on the other hand cannot be simply oxidized into hydrogen peroxide by simple reaction with oxygen. So water does not react with oxygen. Yeah, so why C is actually wrong is that although CO can actually be oxidized to higher oxide, but carbon dioxide or carbon dioxide cannot. So that is why C is actually wrong. Then D, SO2 and NO. So this is actually the right answer, because SO2, which simply means the sulfur 4 oxide, can be oxidized to the sulfur 6 oxide, which is also called the SO3, while your nitrogen 2 oxide or your NO can further be oxidized to the nitrogen 4 oxide NO2. Okay, they are all okay. They all do this by direct reaction with oxygen. Yeah, further reaction with oxygen. So that is what the question was actually all about. Yeah, so that is probably why B wasn't correct. Yeah, because um, further reaction with oxygen, like if you react, like water cannot be like further oxidized into hydrogen peroxide. Yeah, so that is why B is actually incorrect. So moving on to the next question now. So in the preparation of oxygen by heating um, KClO3 in the presence of MnO2, so only moderate heat is needed because the catalyst acts by dash. So in this question, they are just asking you to know the importance of a catalyst in this solution. So in the preparation of oxygen using these both compounds now, so they are not asking you, only moderate heat is needed because the catalyst acts as a dash. Acts by what? A, lowering the pressure of the reaction. B, increasing the surface area of the reaction. C, increasing the rate of the reaction. And D, lowering the energy barrier of the reaction. So D is actually the answer, which is lowering the energy barrier of the reaction. So why is D is actually the answer? So catalysts in general actually manage to increase the and speed up the rate of a chemical reaction by reducing the energy barrier, which is also means activation energy of the reaction. Notes that is also another question. Sometimes you will not see energy barrier, you will see activation energy. So catalyst actually helps to increase or speed up the rate of reaction by reducing the activation energy of the reaction or the energy barrier of the reaction. So the manganese 4 oxide in like present in that kind of reaction actually acts as the catalyst. With that, it presents more heat may be required, to carry out the reaction. All right, so moving on to the next question now, which is question number 10. So we are going to be stopping in question number 10. So it said, methanoic acid mixed with water in all proportion and has about the same boiling point as water. Which of the following method would you adopt to obtain pure water from a mixture of sand, water, and methanoic acid? So this is actually separating techniques, but you to note, okay, in separating techniques, we actually have different type of separating techniques. But in the kind of separating techniques, that actually these on like separating like mixtures, like you know, like that actually have different boiling points. What is it called? It's actually called fractional distillation. If you anyway you just see boiling points, yeah, just know that that kind of separating technique is actually called fractional distillation. So let's see the answer now. Number one, here we actually have fractional distillation. Two, we actually have filtration followed by fractional distillation. Three, we actually have. So let's see why is actually the correct answer. So I actually told you guys about boiling point just now, but let's see more details. Okay, see, we actually have neutralization with sodium hydroxide followed by distillation. Fractional distillation is the separation of liquid mixture into fraction, differing in boiling point. Yeah, so the moment you see boiling point, note that that process actually involves fractional distillation. Yeah. So okay, we are going to be stopping here. So we're going to continue the next episode from this question number 10. So it's going to continue from question number 11. Yeah. So okay, this is going to take from episode to episode. So do follow us for more of this. So okay, then we'll stop here. I hope you got value from this video. Don't forget to like, share, and comment, and subscribe to this channel. All right, see you guys.